Welcome. In this lecture, which has multiple sessions, we'll explore backpropagation. Backpropagation can be thought of as the fundamental algorithm of neural networks. What we'll do is we'll backpropagate scale factors, and the gradient terms themselves will be derived as the inputs to each neuron. This is computationally faster than the linear algebra that we derived in previous lectures. And as we go through this lecture, one problem that we can keep in mind is how can we efficiently compute the steepest descent for a multi-layer neural network? So let's recall what solving a neural network involves. What we do is we formulate an objective function. Here we've been using a squared error. Other errors are also possible. And what we do is we solve this objective by using steepest descent with a fixed step size, which in neural networks is often referred to as the learning rate, eta. And the steepest descent is simply we take our current estimate of the minimizer and then we go in the gradient direction, transposed and negated, and we're using a fixed step size. In a neural network, this weight vector W is a stack of all of the weight vectors for each individual neuron, and we can compute this by layers by working from the output to the input. So let's recall a simple network that we know can solve a two-dimensional exclusive OR problem. We'll flow the data from the top because we think of data as being a one form. So we have the data coming in and it goes through the hidden layer to the output layer, and then it produces the output, which is the activation value for the final neuron in the network. To backpropagate it, what we do is we think first about the residual error. And this residual error is the difference between the label for the data and the output of the neural network at this moment. And what we'll do is we'll take a gradient scale and we'll propagate that backward through the network, working first from the output layer and then through the hidden layer. And if you had a deep neural network, there would be multiple hidden layers that we would have to backpropagate through to find the gradient of the objective function.